Okay, so here I will be transforming the function log of x. Now log of x is this right here. This is the regular function. So it has a 0 of 1, 0 right there, and as it keeps going down, as x goes up to 10, y goes up, y is 1, and so I will be transforming that function by doing a vertical reflection, a vertical stretch, and of 2, and left 3 and up 5. The first thing that you have to do always is the reflection, and to do the reflection I would just need to reflect it over the x-axis and make it go from go from this way that way. Alright, so once I reflect it, it's gonna look like this, and the 0 is gonna stay the same, 1, 0, and then the point that used to be right here will be reflected over the x-axis down here, and it would now be 10, -1 instead of 10, 1. And as you can see, they have been reflected, you see, and okay, after the vertical stretch over the x-axis, I will then do the after the vertical reflection over the x-axis, I will then do the vertical stretch by 2. Now when I do the vertical stretch by 2, I will take these 2 points that I have, and for the first point, what I would do whenever it's a vertical stretch, you will have to multiply the y of any point on the function, multiply it by 2 because it is going on a vertical stretch of 2. So this one would stay the same, 1, 0, because 0 times 2 equals 0, and then for this one, I'll have to multiply this the y value, which is -1 by 2, -1 by 2, and then it would turn into -2. So the new one would turn out to be 10, -2, and when I do it, the graph looks like this. It doesn't look that different, but the points are different, except for the 0, which is 1, 0. And as you see, 10, -2. And for the last steps, I will do the horizontal and vertical transformations or translations, and it's going to be I will do left 3 and up 5. So what I'll do is to move the function, I will just move the 0, this point, and that point, just to figure it out. So 0, 1, 0, I would just have to move it left 3, so I would go 1, 2, 3, and then up 5, 1, 2, 3, 4, 5, and it would be somewhere around there. And then this one, I would do the same thing, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, and it would be somewhere around there. And once I do that, the points, I will put the points where they need to go. So the new point would be right there, so it would move from here to there, and this one from here to there. And for me to be able to know where to make this line going, what I will have to do is find the asymptote, and to find the asymptote is to find, since the first asymptote is the regular asymptote of the log function is as x equals 0, which is this line right here, what I would have to do, so going to the function, as you see the function is up here, what I would do to the function is make the asymptote go left 3, just like I did to this point right here, make it go left 3. So I would make, so I take the origin and then, or make 0, this line go left 3, so 1, 2, 3, and then I get this line, as you see this dotted line right here is the asymptote, and that's how I got it. So I just put these 2 points and I connect them going, and let it keep on going, and this one let it keep on going, but it never touched the dotted line, never touches the line. That's what an asymptote is. It's the part where a curved function never touches, or gets close to 0 but never touches it. So the asymptote of it will be -3. Now the domain and the range. The domain will be x is greater than -3, because no, x will not be able to be -3 because it's never gonna touch the asymptote, so it can't be equal to, because it's never gonna touch the asymptote. It's gonna be very close to -3 but not touching it, so it has to be greater than -3. It doesn't matter how close it is. And then the y equals all real numbers, because either way you go, it's gonna be, the y is either gonna be very high or then very low. It's gonna be positive and negative, so it's gonna be all real numbers. And that's the transform function from log to negative, from negative to log x plus 3 plus 5.